Yeah, so guys, thank you for joining today on a Saturday afternoon. And I really appreciate you joining on a holiday. That shows your eagerness or zeal to learn new things. Okay, so really appreciate it. So today, like we'll discuss. Is my screen visible, guys? Yeah, so screen should be visible. So today we will discuss something, one more last distribution, our exponential distribution, something called exponential distribution. I said only formula will be different, the rest all concepts will be the same. Like you have to, the way you have to calculate probability, the way you have to calculate probability between two limits A and B, probability less than equal to B, less than equal to some number, say probability less than equal to X equal to less than 5. Those things all concept remain the same. Only formula will be different. So if formula is different, I don't think you should have a problem. Only formula will be different. Okay. So before that, I'll let me count like how many distributions we have done. We started with normal distribution. Then we took a special case of normal distribution as p distribution. Then we did a very simple distribution, which is uniform distribution. Then we did our distribution as Poisson distribution. And then we did one more distribution yesterday as Poisson distribution,
Binomial.
binomial distribution. Okay. So like so far we have done a lot of things. And as I can show you, like you can see on the screen, there are a lot many inside. Whatever nine I am showing you here, but there are a lot many others which are not showing you. So there are a lot many distributions, each applicable to model different real life situations. So with the distribution, we model real life situations, right? Right, guys? Right or wrong, guys? Why we use distribution? We studied that we used to model real life situation with the help of distribution. Guys, correct or any problem in this statement?
No, sir.
Correct.
Correct, right? So like yesterday we finished the binomial distribution, and yeah, Jignesh, who sold yesterday, somebody was asking the practical example. So we'll see that practical example. I forgot to take it. So I will see it in the internet after our class. This class is over. Okay. So I'll try to show you
Okay,
one
sir.
practical example from internet. So now we are coming to our new distribution, which is called exponential distribution. And like Jignesh will ask now, we will ask what are the real life applications. So we have a lot of real life. So in front of you, whatever formula is there, what is it? This formula. So lambda 5 f of x colon lambda is equal to e to the power minus lambda x when x is greater than equal to 0. X is greater than equal to 0 to infinity. Fx will be equal to lambda e to the power minus lambda x. And for if x is negative, then it is 0. What kind of things you are is in there in front of you? What you call it? And this distribution is first of all for a continuous distribution. So what is there in front of presented in what is it called, guys? What this formula will give you?
Probability of density.
Probability at what? Probability at giving any given x, right?
Yes.
For any given x, you can find probability with the help of this particular formula. So this is nothing but your probability density function. Why density function? Because you are dealing with continuous variable. Okay, so you are dealing with continuous variable. X is a continuous variable. So probability function, any probability distribution relating to a continuous distribution is called probability density function. Now tell me what is the important parameter in this? Tell me that. What is the important parameter in this formula?
X and lambda.
X is not a parameter. For any X, you are finding the
Endpoint.
probability.
Yeah. So lambda.
Parameter is a constant in the formula. So that is lambda, right?
Yes.
Lambda is a parameter. Is the formula not simple? Now here, if simple one thing, x cannot be less than 0. So x cannot be less than 0 means x cannot be negative. X will always vary from 0 to infinity, positive side only. That is one thing. That is one thing. And for any value of x, suppose you want to find the probability. So that is given by this formula. So provided you know lambda. Okay, lambda, provided you know lambda. So similar to Poisson distribution, here lambda is a rate parameter. It's a rate parameter. So when we'll solve a couple of numericals, you will come to know what is rate parameter. And x is your random variable. For any value of x, you want to find out probability. So 8x equal to 5, x equal to 10, x equal to 15, x equal to 50, x equal to 100. You want to find the probability. Probability will be plotted on y-axis and x will be plotted on x-axis. So x cannot be negative. If you know the lambda, for any value of x, you can find the probability. Is it right or wrong, guys? If you know the lambda, for any
Yes.
value of x, you can find out the probability with this formula. Correct or
Yes.
wrong?
Yes, sir.
Right.
Right, right.
Sir, sir, one question, sir. I mean, you
Yeah.
said no for continuous distribution. I mean, the probability can be, sorry, the x can be minus infinity to plus infinity.
Yeah.
So then, I mean,
But
in this case,
here is something like no, it can be minus infinity to infinity. That is in case of normal distribution and t distribution. But in Poisson distribution, we are counting events. So how can x be negative? X is nothing but number of events, right? So number can never, counting can never be negative. So here also x is something similar. So here x cannot be negative. We are dealing with such phenomena, real life phenomena, where count or this x cannot be negative. So it depends on what kind of situation, what of real life phenomena you are doing, you are dealing with. Suppose you are counting some events, like in Poisson distribution. It cannot be negative, right? Number of count can never be negative. Count can be zero, but can I say it is minus 5 number of flights which are coming in every 2 hours in an airport? Can I say that? Can I say that minus 20 flights coming every 2 hours in an airport? Will it make any sense?
no, sir.
So
So, but when we are saying there's a continuous, then I mean,
20 flights, it's a continuous, but it is continuous between 0 and infinity. Minus is not there. Understood. Some distributions like the normal distribution and t distribution, x is continuous and it is lower value is minus infinity, upper value is plus infinity. But for certain distributions, x cannot be negative because it is represents such kind of physical phenomena where x cannot be negative. Random variable cannot be negative. Okay. So for all variables, x is not minus infinity to infinity. Now, in some variable, x is a continuous number between minus infinity to infinity, like your normal distribution and t distribution. X varies from minus infinity to plus infinity. In case of Poisson distribution, x is a discrete number. So it is a count. So it varies between 0 and infinity. Similarly, for exponential distribution, sorry, for exponential distribution, like your x varies from 0 to infinity, not, it cannot take negative values. Okay. So it depends on, like, see, a continuous number in general, if you say any continuous in general, without any reference to any probability distribution, it varies from minus infinity to infinity. But for every distribution, there is a range of x which makes sense for that distribution. So for normal distribution, the x range can be minus infinity to infinity. For t distribution, it can be minus infinity to infinity. But for Poisson distribution, minus has no meaning. Only it can vary from 0 to infinity. So similarly here also, for exponential distribution, negative value of x doesn't make any sense. It varies from only 0 to infinity. Continuous number, any number between 0 to infinity. Got it? Right.
yes, sir.
Amit Parik got it.
Yes, sir.
So like, it depends on what kind of physical phenomena you are dealing with. I'll tell you in the when numerical example comes. Now CDF. So CDF is nothing but you know that suppose if I want to calculate probability of x equal to 5.5, probability exactly at x equal to 5.5, then I can use this formula, right? It is a PDF formula. So probability of x value x equal to 5.5. So what is the probability? I can find out with the help of this formula. So that will be only one value of probability. But suppose, what if I want to find out the probability of x less than equal to 5.5? So x varying between 0 and 5.5, all the values I want probability. So there will be multiple probability values. Here x is less than equal to 5.5. Okay. So x is less than equal to 5.5 means there will be multiple values of probability I want. So in such a case, the function will become CDF, cumulative density function. You are aware with these things, right, guy? Okay, guys, am I
Yes,
making
sir.
Yes.
sense or
Yes,
not?
sir.
See, a value of x exactly equal to 5.5, there is only one value of probability. There is only one value of probability. So that is given by your probability density function, right? So probability density function is nothing but this function, lambda e to the power minus lambda x. But if I want value less than equal to 5.5, so there will be multiple values of probability, right or wrong, guys?
Right, sir.
X will vary from 0 to 5.5. So there will be multiple value of probability. That's what I want. So that is given by my CDF. So CDF is given by capital F, which is see the box which is there in the box. Inside the box, I have put CDF. So CDF is nothing is the probability density function is represented by small f. But the CDF, which is cumulative density function, is represented by capital F. So cumulative is given by 1 minus e to the power lambda x. So it's an integration actually. So suppose I want probability between 0 and 5.5. So a integration of x lower limit 0, upper limit 5.5, and I'll put fx dx. Fx is nothing but your small f, which is your probability density function. So somebody has already done that integration for us. Relative is given by 1 minus e to the power minus lambda x. So suppose I want probability x less than equal to 5.5, less than equal to 5.5. Then I'll use this capital F function. Value will be given by 1 minus e to the power minus lambda x. So value I want less than 5.5 means lambda value I know, so x I'll put at 5.5. So it will give me all the value like cumulative probability between less than equal, the cumulative probability of x less than equal to 5.5 means x varying between 0 and 5.5. Got it, guys? So there are two functions here. One is probability density function, which is lambda a to the power minus lambda x, which will be give you probability at a specific point. Specific point in x equal to 5.5. Then there is a cumulative probability function, which will give you values less than equal to something. X less than equal to 4, less than equal to 6, x less than equal to 2, or between x lying between 2 and 4. So suppose lower limit is 2 and higher limit is a. You want cumulative probability. So such formula, such a thing will be given by your capital F. Got it, guys? Jignesh, Amit, got it? The
Yes,
difference
sir.
between PDF and CDF, this we have discussed multiple times.
Yes,
Same
yes.
concept applies here, only formula is different. So CDF, your PDF is probability density function is lambda e to the power minus lambda x. X is greater than equal to 0. Okay. And your CDF means cumulative density function is 1 minus e to the power lambda x. Same x is greater than equal to 0. Okay. Guys, got it? So this is the formula for PDF. Capital F is the formula for CDF. Got the difference? Now there are some condition for this particular with internet connection. There is some problem, I think. Okay. So now there are now Jignesh will ask like Jignesh, you only asked last time the question, right? What are the real
Yes,
examples of binomial distribution, right? Jignesh asked or
yes,
somebody else asked?
yes, yes, sir.
So now you want example of exponential distribution. So exponential distribution always represent time interval between two events. Suppose one interval like yesterday, one earthquake occurred in Delhi. Suppose, for example, suppose today is what date? Today is what date? Today is 7th, right? So 7th of 6th of January or 5th of January. Suppose there was a earthquake in Delhi. Now my next question will be, as a town planning authority or as a government guy, when can be the next earthquake? That is the natural question, right? One earthquake was only yesterday. But then my next question to the scientist will be, the geotechnical scientist, I can ask the question, when will be the next earthquake? Is it not a natural question to ask? If you can predict when can be the next earthquake, you can do some preparations, right? If there is some earthquake is big, whatever discretion, life and property loss will be there. For that, you can prepare your hospitals, your transport, ambulances, those things you can prepare. So yesterday, suppose yesterday was one earthquake. If I can predict when will be the next earthquake, so is it not a useful information, Jignesh?
Sir, it's a very much
Very much
informative.
useful. So this time interval between two earthquakes, that's what we can predict with the help of a exponential distribution. Now I'm an airport manager. Okay. So suppose one flight landed. One flight landed just now. Just now, before 1 minute, one flight landed. Now my next question can be like, when the next flight will land. So next flight suppose will land 5 minutes later. So what is the probability next five flight will land? So next flight will land 5 minutes later. So this kind of time interval I can calculate with the help of exponential distribution. So exponential distribution is nothing but the time interval between two events. So that is one earthquake has occurred yesterday. So when can be next earthquake? So that time interval I'm interested. So such kind of things can be predicted with the help of exponential distribution. So another example. Okay. So used to be, suppose we are in a company, you are working in a company and sitting, there is a operator, there is a operator, telephone operator is there in the night. And suppose there is a long distance call is there in Ahmedabad and there is a long distance call coming from New York. Suppose that long distance call came 8 p.m. 8 p.m. And now your long distance calls are not coming very frequently. Majority, suppose in your company, majority calls are from India only. So one long distance call has come from New York. So like my next question may be, can I go for a tea? Can I go for a tea or coffee? So my next long distance call, how much time interval my next call will be from New York? Our next call will be for a long distance call. So that much time interval, if it is large, suppose I predict that next call now will come only after 15 minutes. So I can leave my seats for 5 minutes, right? Then another example is your car battery. Suppose you have a car and you changed your battery yesterday. You changed your yesterday. Now your next question will be, when I will need the next battery change? 2 years, 3 years, 4 years. So that kind of time interval between two battery change. So one battery change was an event which happened yesterday. Now you can ask the question, when my next battery change will be required? Is it after 3 years? Is it after 4 years? Depends on your usage. Now one earthquake has occurred yesterday. So as a town planning authority, as a town authority or as a government guy, I can ask a question like, when can be the next earthquakes? Those kind of two events are happening. Between that, what will be the interval? That kind of questions are, that kind of things can be answered with the help of, that kind of questions can be answered with the help of uh, exponential distribution. Got it, guys? Jignesh, Amit, Sarthak,
Yes,
what
sir.
is the use? Like where we use it? But you see,
Sir,
in compared to that, your Poison distribution, I am not counting time between the events. In Poison distribution, I am counting the events.
Event possibility we are counting. No?
Flights landing on an airport are event, yeah. And here time between the interval we want. So see, suppose there are 120 flights landing between average is 120 flights every 2 hours. What is the probability of me getting 200 flights in a random 2 hours? Any slot, any other future 2 hours, what is the probability of getting me 200 flights? So these kind of events we are counting. Here we are counting time between the interval. Okay, so one earthquake occurred yesterday. So when the next earthquake will occur, that time gap I want. One car battery I changed yesterday, when I will need next battery change. So 2 years, 3 years. So that kind of time gap I want. Now my long distance call was 5 minutes back from New York. So when can the next long distance call? So those kind of time intervals we are talking about it, exponential distribution. Okay. So like in Poisson distribution, exponential distribution curve also depend on the value of lambda. Lambda is the only parameter in that. X is a variable anyway. So X value will vary from 0 to infinity. But parameter is only lambda. Parameter is only lambda. So value of depending on the lambda, value of lambda, you will have your exponential distribution curve. You can see the colored. The orange one is lambda equal to 0.5. Then the dark blue is lambda equal to 1. And the one like which is very light and coming from the top, it is lambda equal to 0.5. And for every equal to one value of lambda, it will be like it is a explanation for you, or Amit, you were asking this question in Poisson distribution. So
Yes.
here every value of lambda will be a different distribution. Got it? For lambda equal to 0.5, there is a different distribution curve. Lambda equal to 1, there is a different distribution curve. Lambda equal to 1.5, it's a different distribution curve. So physically, they are all representing different phenomena. Lambda equal to 0.5 is one phenomena. Lambda equal to 1.5 is one phenomena. Lambda equal to 1 is one phenomena. Got it, guys? Got it, Lamit? You got it? Is it clear to you?
Yes, sir.
Okay. So
Sir,
different events, different phenomena there. Yeah, tell me.
sir, is there any possibility that this distribution can be a normal distribution curve any point of time?
Yeah, we are getting to that. We are getting to that. See here. Now here next is that question only. See the lower bullet, left hand side. To see the lower bullet. Distribution approaches normal distribution. Your value of lambda gets larger. So value of lambda gets more than 10 or more. Then your exponential distribution curve approaches normal distribution. Poisson distribution also we saw the same thing. When lambda is more than 10, Poisson distribution also becomes normal distribution. Here also, when lambda becomes more than 10, the curve will exactly become normal distribution. See the plot. That yellow dots which you are seeing, that is lambda equal to 1, it is coming from the top. Lambda equal to 4, the purple dots you see, that is nothing but right skewed, like right tail is longer, it is not symmetric. But for lambda equal to 10, you can see which is light blue dots, right? Light blue dots. So that is a perfectly symmetrical curve. And if you plot for lambda equal to 20, you cannot differentiate between normal distribution and exponential distribution. Guys, you got your answer, Amit?
Yes, sir.
So when lambda equal to 10, for any event, when lambda equal to 10, for any phenomena, if lambda equal to 10, for any real life phenomena, if lambda is more than 10, then you can model it either with the help of normal distribution, or you can model it with the help of exponential distribution, or you can model with the help of a distribution. There is no difference. Got it, guys? Amit, got it?
Yes, sir. Yes.
And what about Sarthak and Jignesh? You got this?
Yes, sir.
Yes, sir. Sir, in that
Okay.
sample size will be?
Sample size will be good question. So sample size,
Yeah, any condition for
sample
that
size
sample size?
again. No, there is a condition for sample size. There is a sample condition. There is a sample condition. sample condition, like lambda values given. Good question you are asking. So I will it solve now and now and now and there we'll solve it. That I never queried it to Google God is there, no? So what should be the minimum sample size for exponential distribution? See, somebody has already asked this question. So exponential requires only 10 samples. Got it? Vignesh, can you see the
Okay, sir.
screen? It
Yes, yes.
exponential and exponential requires normally requires only 10 samples or above.
Okay.
Okay. So that is general sample size for your sample size, and there are different. So now there is a difference between exponential and Poisson distribution. So exponential distribution, we are interested in time elapsed between the events. Like between two events, we are interested in time. How much is the time between two events? Poisson distribution, we are interested in number of events, right?
Yes, sir.
Distribution is for a continuous number. Poisson distribution is for a discrete variation. You got some important differences between exponential distribution and Poisson distribution,
Yes,
guys.
sir.
Now here one more time I have written like Poisson distribution and exponential. It's more explicitly written. See here, in Poisson distribution, your x can be 1, 2, 3, 4, 5, 6 like that. It's the event number of events. And in exponential distribution, your x is the time. See, you can see the orange one here on the right hand side. It is the time between two intervals. So two events are shown. In that, with the help of a bracket, we are showing time. Okay. So in that time, we are interested when it is exponential distribution. And when it is a Poisson distribution, we are interested in number of events, every number of events. Or in x will always represent number of events. And Poisson exponential distribution, x will represent the time between two events. Got it, guys? So same thing again and again. It's one more example I want to give. One good example you see in the last in this table. There is a last. So suppose there is a machine in a factory. Okay. Suppose you are in. Suppose there is a machine in the factory, and average number of breakdown are say 10 breakdown per month. It is observing average number. Average number is 10 breakdowns per every week. It is giving 10 breakdowns. So 10 times you have to repair it every week. Okay. So this breakdown, every breakdown is the event. Just give me a second. I have to. Sorry guys about the disturbance. See, there is a machine in a factory. Average number of breakdown is 10 per month. So lambda in Poisson, it will be modeled by Poisson distribution, right? So now if there are average number is 10, now as a maintenance manager, I may be interested. What is the probability of me getting 15 breakdowns per week, right? So 15 breakdown is the 15 is nothing but your x, and average 10 breakdown per month means lambda equal to 10. Like that, you can model with the help of Poisson distribution. Now the same machine, like I did the maintenance, like there are 10 breakdowns average per month. Now one repair occurred only today, and I want to go on leave, like as a maintenance mechanic. So suppose I'm a maintenance mechanic who is very important to the machine repair. I want to go on a leave. I will go on to a couple of days leave. One breakdown was repaired today only. Today morning, one breakdown was repaired. So if you want to go on leave and you want 2 days leave, so as a manager, I will be interested in knowing whether next 2 days Next 2 days when this guy will be on leave, this mechanic will, what is the probability of not a information? See, that guy wants 2 days leave. Now, one breakdown occurred only today. So next wants 2 days leave. So as a manager, I would be interested in knowing whether next 2 weeks, next 2 days, any breakdown will occur or not. This kind of. So understood the difference between when to apply Poisson distribution, when to apply exponential distribution. Guys, Jignesh, you got it? Can you
Yes,
hear
sir.
me? Like, and
Yes, yes.
Sarthak, Amit, you got it? How, like, when do you apply, when to apply Poisson distribution and when to apply
Yes,
exponential distribution? Got it, no,
yes, sir.
guys?
So, yes, sir. In my terms, can I give you a small example, sir?
Please go ahead, Anna.
Yes, sir. So for how many times the market
Oh, most welcome.
can,
Tell me.
sir, I'm audible?
Yes, Amit bhai.
Yes, you're audible. Go ahead.
Yes, yes. So how many times in a month market can go down? If that I have to calculate, then I can go for Poisson.
In how many times
Times,
market is going to go down
yeah,
from a particular level? Suppose current level is 60,000. So how many times market can go in a month? Can mark how many times it can go below 60,000? So that you can apply Poisson distribution. Now tell
yes.
me when you will apply exponential distribution.
After what time interval it can crash or it can correct, that I can do with the
Yes.
exponential.
So my current level is suppose 62,000.
Yep,
Now, suppose my current level is 62,000, current market level, BSC
yep.
index.
Hmm.
So next time I want to know the interval, like how
Yes,
much time interval, like maybe 15 days or 1 month, it will go below 1 month, below
yes,
60,000. Today
yeah,
is 62,000. I want to know the probability between like how many days or how many months it will take to go below 60,000. Those kind of time intervals I will find with the help of exponential distribution. Guys, got it?
yes,
So now I think you are all set to go to numerical examples. And Jignesh Bhai asked a new good question that how much is the sample size? So we got the answer. Approximately if 10, there we have 10 samples or more, we can work with your. So I will not take you to this. You can go through yourself relationship between exponential and Poisson distribution. See here now, I points to remember. Like there is some points to remember for suppose for your knowledge only. Exponential distribution is a special case of gamma distribution. Gamma we have not studied in this particular class, and I'm not going to cover it. But if you just for knowledge you remember, it is something gamma distribution is something. Maybe I have given here gamma distribution. Yeah, so gamma distribution second row first one. Second row first one you can see that purple plot which is right hand tail is more. So it looks like that gamma distribution. So exponential distribution is a special case of gamma distribution, and we are not going into detail of gamma distribution. Just for knowledge, we want to know it is a special case of gamma distribution. Poisson distribution is normally derived from binomial distribution. Both are described. Like binomial and Poisson distribution are very closely related. Both are for discrete number. So Poisson distribution formula is generally derived from mathematical X statistics people will derive Poisson distribution formula from binomial distribution. Both are very closely related. Poisson distribution can also be derived from exponential distribution. So like Poisson distribution, which is discrete distribution, can also be derived from exponential distribution. These are just point of knowledge I wanted to give you. And we are not going any details like how to derive and all. We are not going. Yeah, some noise was coming from kitchen, so I asked them to close the kitchen door. Next door is kitchen actually. So a lot of noise was coming. So these are the just point to remember actually. So we are not going in any more details. Now, now we are going to do some numerical examples. So before that, we want to understand the formula. The probability distribution function means what is the probability distribution function? Probability at any given point x at probability at x equal to 5.5, x equal to 10.5, x equal to 50, x equal to 100.1, any given value of x. Suppose if I want to find what is the probability, so that is given by lambda e to the power minus lambda x. So lambda is a rate parameter. It's only one parameter, and x is your variable, random number. Now mu, mu is given by 1 upon lambda. Exponential distribution also, mean is given by 1 upon lambda. And variance, so variance is given by 1 upon lambda square. These are simple formulas where to remember. Mu, which is mean, is given by 1 by lambda, and variance, which is sigma square. Sigma is nothing but your standard deviation. So variance is always equal to sigma square. It is given by 1 by lambda square. So these simple formulas we have to remember to do couple of numericals here. So I'll take only one bigger numerical I'll take up, and then I think we can close. So this was your revision. Like probability density function is lambda e to the power minus lambda x. Mu is like, which is mean. Mean of that distribution is nothing but 1 upon lambda. And variance, which is sigma square, the standard deviation square, that is given by 1 upon sigma, 1 upon lambda square. And one more formula I want to revise you, which is nothing but nothing but that standard like a CDF. If you CDF, you will be always required to calculate. CDF is always required. CDF means what is the probability of x less than equal to 5, less than equal to 10, between 5 and 10, those kind of multiple probability values. And suppose cumulative value, if you want to find out, that is area under the curve, then you need CDF. So your CDF is always equal to 1 minus e to the power minus lambda x. And your x will always, in exponential distribution, x will always be greater than 0. Greater than 0 or 0. So it cannot be negative. So formula is 1 minus e to the power minus lambda x, that is CDF. And lambda into e to the power minus lambda x, that is your PDF. So these formulas we have revised now. We'll take only one nice numerical which will cover all the cases. And see here, so exponential distribution. CDF x less than equal to x is given by 1 minus e to the power minus lambda x. Your PDF is given by, that is like your CDF. This is CDF formula. This is not PDF formula. This is CDF formula. So CDF is 1 minus e to the power minus lambda x. Now I want you to be ready with your copy and pencil. I'll ask you simple things to do that you have to do. Okay. So just be ready with your copy and pen and copy and pencil. So just keep it by. You want me to take a 1 minute break to allow you to collect your copy and pencil, guys? Or it is a handy with you?
Sir, it's
Yeah, we have.
अमित भाई गायब हो गए क्या? We'll solve a numerical example. Simple example we'll take. Okay.
Yes, sir.
You have copy and pencil ready, Amit bhai?
Yes, sir.
Okay. So now we are dealing with time interval between events. So one event, now here event is starting of the phone call and ending of the phone call, means duration of the phone call. Duration of the phone call is what we are dealing with. So one event is starting of the phone call, another event is ending of the phone call. So time interval between start and end of the phone call we are taking as our x variable. So assume that length of phone call in minutes in an exponential random distribution is x. So x is nothing nothing but call duration. Call duration is our x with parameter lambda equal to 1 by 10. So lambda equal to 1 by 10 already given to you. So see in this formula, in this formula, like lambda is the only parameter, and he has given you lambda already 1 by 10. Done. Your job is already done. So now, if someone arrives at the phone booth, like olden days, we used to go to phone booth, right? Like if you remember, like Sarthak was might be very kid, like maybe 10 or 12 years old. That time we used to telephone booth for making long distance phone calls. Suppose I had to call to New York or London. Those things I cannot do from home, so I would go to a telephone booth and I'll pay some money to him, and then I can make a phone call.
Yes,
Okay.
sir. STD-PCO.
STD PCO, yes, exactly. So STD PCO we used to go. So suppose we used to go to a phone booth. So just before you arrive, find the probability that you will have to wait, like somebody was already calling. When you arrived at the phone booth, somebody else's call just started. Now, what you have to find out the probability that his call will finish in less than 5 minutes. That is one probability you have to find out. Case A is you have to find out how much is the probability that his call will finish less than 5 minutes. That is one probability. Another B question is you have to find out his call duration, the guy who is already talking in the phone booth, whose call duration will be more than 5 minutes. That's what you have to find out. And third, as a C, you have to find out what will be the probability that the guy who is already talking, that person's call duration will be between 5 and 10 minutes, right? So that these probabilities you have to find out. And after that, you have to find expected value. Expected value means expected value is another name given to mean value. So mu. So another name given to it is another synonym or another name given to is expected value. And then you have to find variance also. So see, expected value is nothing but mu equal to 1 by lambda. Variance is equal to 1 upon lambda square. That's what you have to do. Lambda is already given. So expected value you have to find out. So that is nothing but 1 upon lambda. And variance you have to do. So that will be 1 upon lambda square. Already lambda is given to you. Okay. So lambda, how much is lambda? 1 by 10. So let us solve first problem. How will you solve first problem? I want you to give your mind to it first. How will you find the case A? Will you apply PDF or CDF? Will you apply PDF or CDF in this case?
CDF.
CDF, right? Why CDF?
Less
Because
than
you want to find out duration less than 5 minutes. So it can be anything between 0 minutes to 0 to 5 minutes, anything. So you want cumulative probability. So that's what you will apply. That's when you will apply CDF. Got it, Sarthak and Amit? Is it clear to you?
yes, sir.
Yes, sir.
And if you've done a case number B, greater than 5 minutes, you will apply PDF or CDF.
Again CDF, sir.
Then how will you calculate now?
So from 5 to 10, that
1
cumulative.
minus less than
5 to infinity. Na? B is greater than 5 minutes, so it can be go from 5 minutes to infinity. So you have to, like, how will you find out? Yeah, Jignesh was correct. Like Jignesh, go ahead.
1 minus less than 5 minutes.
See, he has told already. Given the solution between 5 minutes and 10 minutes. How will you calculate? Between 5 minutes and 10 minutes. Will you apply CDF or PDF?
The range is given.
Range,
So,
yeah, range.
1 minus less than 5. We need to calculate like that. 1 minus less than 5 and greater than 10. 2 minus we need to do.
No. See, first of all, will you apply PDF or CDF? Which formula you will apply?
Okay. That is interval we are checking.
So see,
It's a
first one was also
CDF.
interval only, na yaar. Less than 5
CDF,
minutes means 0 to 5 minutes.
Yeah,
First
CDF
one
only.
was also 5 interval only, 0 to 5 minutes. So C
CDF.
also 5 to 10 minutes. You will apply CDF or PDF?
CDF.
Which one?
CDF.
CDF, right? So once
Yeah.
what you will do, first of all, you will calculate less than equal to 10 minutes. Like with CDF, you will calculate less than equal to 10 minutes. That is one thing
Yes.
you will calculate, right? Then you will
Yes.
calculate less than equal to 5 minutes. That's what you will calculate second. Then less than equal to 10 minutes minus 5 minutes. less than equal to 5 minutes. Is it not between 5 and 10 minutes?
Yes, sir.
First, you will calculate what is the time between 0 and 10. Then you will find out the time between 0 and 5. So from 0 and 10, you will subtract time from 0 and 5. Then it will give you time between 5 and 10. Got it, guys?
Yes, sir.
Sarthak and Amit, have you got it?
Yes, sir. Yes, sir.
Yes, sir.
Okay, so now you have already solved it because now it is just question of keeping in formula. Okay, so now see, first part A, less than equal to 5, lambda equal to 1 by 10. Lambda equal to 1 by 10. Formula is CDF formula you have to apply 1 minus e to the power minus lambda x. See, here CDF formula is 1 minus e to the power minus lambda x. Okay. So lambda value is already given as. So what is the value of x here? Jignesh.
Less than or equal to 5.
So what is the exact value of x here that you will put? You cannot put less than or equal to 5. What the exact value of x you will put?
Okay. So we need to calculate for separate, or we can directly calculate.
See, here less than equal to 5 means you will put x equal to 5 only. Automatically this formula
0
will
to 5 we
calculate.
need to calculate. Yeah, fine.
If it is less than equal to 5, you will keep x. This formula will automatically give between 0 and 5. Less than equal to 5,
Okay.
this formula will automatically give. Because this is CDF formula. Got it?
Yes. Then it
So
start
now
with 0.
x is lambda is 1 by 10. X is 5 and lambda is 1 by 10. Just put in formula and calculate. Yeah, it is 0.39. Is it understood, Sarthak and Amit?
Yes, sir.
Lambda is 1 by 10 and x equal to 5. If you keep in this formula, can't you calculate the value? It is 0.39. So probability was first question, like part A was, what is the probability of that guys who was talking already that his call will finish less than 5 minutes? So 0.39. So 0.39, 40, there is a 40% chance that he will finish his call within 5 minutes. Now next, what is B is what? Greater than 5 minutes.
Yeah,
Greater than 5
0.60.
minutes. Huh?
0.60.
Yeah, so it will be less than 5 minutes to deduct. See, here it is a misprint here. He has given x is greater than 10, so it's a misprint here. It should be less than equal to 5. So it's a wrongly solved. So you do just one probability of 5, right? Got it, na? So 1 minus, suppose like less than, suppose we are asking now greater than 5 minutes. So greater than 5 minutes means 1 minus 0.3934. Got it? So now next question, see here. The question was greater than 5 minutes. So before the 0.3934. So 1 minus 0.3934 will be probability of more than 5. X varying between 5 to infinity. Got it? Guys.
Yes, sir.
Amit and Sarthak, you got? Jignesh bhai, you got it?
Yes, sir.
Yes, sir.
Your yes is coming very like low, like Amit bhai. You are not understood, looks
No,
like.
no, sir. I understood. I mean, it's a simple, sir. I mean, we have already calculated the earlier part, so that's why. I mean, we are
1 minus, if you do
Yes.
that, will it not get greater than 5?
Yes, sir.
That's what. Sarthak, Jignesh, so don't see here he has misprinted. He has calculated greater than equal to 4. So you don't go on that. He has miscalculated it. So here he has done some misprint and miscalculation here. So now you know how to calculate. Okay. So now compute between x varying between 5 to 10. So don't go by his method. I'll tell you, first calculate, first apply CDF. First apply this CDF. CDF means 1 minus e to the power minus lambda x. So first apply for x equal to 10. So x equal to 10 and lambda will be 1 by 10. That will be one case. So x will be less than equal to 10. X is less than equal to 10 means x will be 10 and lambda will be 1 by 10. Do calculate one that. Then another case you take less than equal to 5. So lambda will remain the same. Lambda is 1 by 10 and x is your 5. So you just subtract now to x less than equal to 10 minus x less than equal to 5. You will get the answer. Got it, guys? Or there is a confusion here, guys? Amit?
Sir, need to repeat. I'm sorry, sir, but I mean, conceptually, I did not. I'm not clear, sir.
See, this we have discussed. Like you want to calculate between this you want to calculate, right? Probability of x varying between like his call duration more than 4 but less than 10 minutes. Okay. So now I will apply CDF. I'll apply CDF, cumulative density function, to calculate call duration between 0 and 10. So it is less than equal to 10 I will apply. So in this CDF formula, I'll keep x equal to 10 and lambda equal to 1 by 10. So I'll get probability that what is the duration of this is called less than equal to 10 minutes. Now you got it, Amit by this first part.
Yes, sir.
So less than equal to 10 minutes, you got it now, right? Now what do you want? You want between 5 and 10 minutes, right? So now next you put less than equal to 5 minutes, less than or equal to 5 minutes. So 0 to 5. So here if you put x equal to 5, lambda equal to 10, you will get between 0 and 5. I cannot plot
Yes,
it,
sir.
otherwise I have plotted and shown. So now you
No,
have
no.
two values. One value is between 0 and 10, another value is between 0 and 5. So between 0 and 10 minus between 0 and 5, if you do, will you not get between 5 and 10?
Yes, sir. Now understood.
Sarthak understood, Jignesh understood.
Yes, sir.
So now just you solve by your method, don't go by his method. You apply whatever we have discussed, you will get the answer. So now see, he has done with some different method. I don't want to confuse you with that. So you just put with the CDF formula less than equal to 10, then you calculate less than equal to 5 and subtract both. You will get the answer. Simple way. Now expected value is very simple, 1 upon lambda. So mean value, mean is like mean call duration is 1 upon 1 by 10. So mu equal to 10. So mean means his call can, like, suppose he talks so many times, so mean call duration is 10. And variance, so variance is 1 upon lambda square, that is 100. 1 upon 100, if you do square, it will be 100. So you are done. So now I want you to like ask some questions. Anything in this numerical example, if it is not understood, please ask. I have finished my lecture actually. So please ask if you have not finished, if you have not understood anything in this lecture. You know how to calculate less than equal to 5. Just put x equal to 5 here. You want greater than 5, so it will be 1 minus x less than 5. So that you will get B part. And C part means first you calculate x less than equal to 10, x less than x between 0 and 10 you calculate. So you have to just put x equal to 10 here. Then you calculate x 0 and 5, between 0 and 5. So you have to put x equal to 5 here. Just subtract the two. You will get the answer for C. And expected value and variance, so you don't need to put your mind. It's just 1 upon lambda. If you do 1 upon lambda, it will be your mu. That will be expected value. And if you do 1 upon lambda square, it will be 100. That will be, you don't have to put any brain there. Just put in formula. Jignesh, sorry, Amit Bhai, have you understood how to solve this numerical problem?
Yes, yes, sir.
100%? Sarthak,
100%, sir.
Jignesh,
Yes.
Jignesh Bhai, Jignesh Bhai, what is happening here? Jignesh
No,
is not
maybe
there.
his audio or network connectivity.
Some problem is there. Okay. So, like only this example, if you do, I think now you have understood Poisson distribution. You know now normal distribution. Now you know T distribution. Now you know uniform distribution. Now you know Poisson distribution. Now you know exponential distribution. And now you know binomial distribution. Out of that, two are for discrete. So binomial and Poisson are for discrete, rest all for continuous. Binomial and binomial and Poisson are for discrete. Remember that, binomial and Poisson. So BP means blood pressure, like blood pressure. So B means binomial, P means poison. So BP is for discrete. Rest all is continuous, whatever we have discussed. So with this, I there are number of misprints when you do read from the web and all. There are number of misprints. So you have to be little bit careful. You see here, part B is to calculate greater than equal to 5 minutes, but is calculating 10 minutes. Greater than equal to 10 minutes is calculating. But in the question is greater than equal to 5 minutes. So he has to do 5, no? So instead of 5, he has printed 10 here. Now here also, he should be between 5 and 10. He has used some different complex method. Simple method was once calculate for 10 and once calculate for less than equal to 5. Just take a difference. You will get 5 and 10. Simple. So he has like he might have done correct only, but some complicated way where you have to spend more, you have to break more head. Okay, so now here expected value is very easy, 1 by lambda and variance equal to 1 by lambda square. Jignesh bhai, can you hear me? Now I wanted to find out, can you call bhai Jignesh bhai, what is happening, Amit bhai? I want to
Yes.
calculate, see one example of Poisson distribution for him. No, one example of binomial distribution. So I wanted to search web. So it was specific his question. So that's why we want Jignesh to be present. Just call, ask and call him. Yeah. Nobody. So real time binomials.
I guess sir he got some call from office or something. So his I mean phone is also
Okay,
busy.
okay, no problem. So we will take it that in the next class.
Sure. Sir.
So you know, that let because it was his problem only.
I guess he's back. Hi Jignesh bhai.
Jignesh bhai, you are back.
Yes, sir. Sorry. एक
No
call
problem,
मिलता है.
Jignesh bhai. Life is like that. See, real life means rolling a die. See, Jignesh bhai, they are giving real life example means rolling a die. So rolling a die is one example. Tossing a coin, but they are not real life example. Yeah.
Yes, yes.
So here real life example is given. So I'll make it little bigger. You can read it here. Can you read it here? Defective items.
Yes, yes. Defective item. Yeah.
Yeah. So I will make it little bigger. So see, defective item means even I am reading for the first time. Let us read it. So probability of finding number of defective items 0 to 30, 0 to 30 while examining 30 items. Okay. So means total 30 samples are there. So we want to want to find out probability, like what is the probability of getting 1 defective, 2 defective, 3 defective, or all the 30 defective. That's what we want to find out. Okay. And here the random variable X is the number of success. Number of success means X is number of defective part. Probability of
Yes.
getting a defective part is X here. Okay. That is the number of times defective items found out. The probability of finding defective item P is the binomial distribution. Suppose, so B equal to 30. 30 means your number of size n equal to 30 and probability of success. So now my question should be my question can be like that. I have 30 samples. I have 30 samples. See, now first of all I want to find out P. Find out P. P means from previous data I will know that out of 30 items, generally 10% are defective. Generally.
Yeah.
So that
तो we
data I
can
will know. That data I will know. So my P will be equal to 10%, 0.1. Okay. So now my n will be equal to 30 because there are total number of 30 events, 30,
Event. Yes.
30 things I'm checking now. So
Yes.
30 n equal to 30. Now my question to you will be, if generally I found out 10%, generally in the past, I have my average was 10% defective item. Now today, if I'm doing 30 items, what is my probability of getting out of 30? What is the probability of me getting 10 defective items?
Okay. So X equal to 10.
X equal to 10. So out of 30, I want to know what is the probability of me getting 10 items defective. So what is the probability? 10 divided by 30. My average probability is 0.15. But now today I want the probability 0.33, like 10 divided by 30 means like 0.33
0.33.
only, right?
Yeah.
So I
Yes.
want to find out of 30 items, what is the probability of getting 10 defective items.
Yes.
Now, if you tell me, I'll give you a practical scenario where it can be
Yeah.
useful.
Yeah. Yeah. Got it, sir.
No, let me give you one simple scenario. You got it, but let me give me a simple scenario. See, like a very costly part I'm producing and my deadline is reaching. Very costly part I'm producing on a particular machine, and suppose my deadline is so my deadline is 1:30 p.m. now. 1:30 it has to dispatch, and right now it is 1:16 p.m. Okay, so my average rate defective, I know that my average rate was 10% only. 10% fine. So out of this 30, generally in the past I have found only 3 defective. Now today my deadline is as 1:30 p.m. So what is my probability of getting more than 3 defective? See,
Okay.
if more than 3 defective are there, I cannot prepare in 15 minutes, right? So I'm not planned for it. So that's a problem. So what is my probability of getting more than 3 items defective today? So your X will be greater than equal to 3. You have to apply cumulative distribution formula.
Yes.
Got it,
CDF.
guys?
Yes.
Generally,
Yes.
I find 3 defective. Today, what is my probability of getting greater than 3? Greater than 10% or greater than 3 out of 30. Okay. So I have to apply CDF formula. That's where I can apply binomial distribution. So it's a discrete distribution because I am like, it's a discrete distribution. We are dealing with discrete numbers. Got it, guys? So like there are so many given here. So I can share this with you, like high drinking, like so many examples are given. See, so one we have discussed here in the class, and other I will give you as a, like I will give you in the chat box. You can in chat box you can just copy and you can have a look. Okay, got na Jignesh bhai?
Yes, sir.
So now that if you don't have any question, then I will finish with we can finish today's lecture, and that's what is today's lecture. And the next lecture I will show you what next lecture will be, so that you have see. So videos. Just bear with me for a minute. I will get you to that. It's very statistics presentation. See, there are total 10, 11 slide decks I have made, and we have finished today 6 one. 6 we have finished. So next one will be your set. Now all the probability is finished now today. All these are all probability distribution, right? So PDF, CDF, and whatever basic laws of probability, everything is finished. And we have taken 14 lectures of probability, which is a very detailed study of probability we have done. And if you revise it properly, if you revise now properly, only this, even if you revise only the PPTs, now that would be enough for you. So your probabilities should be very strong now, but you have to revise it once. Now next I will show you. So next is going to be very interesting, which is your probability. So we'll be talking about sampling methods, and it's a theoretical thing. We'll be talking about sampling methods, population sample, sampling methods, and type of statistics. What are the basic type of statistics? So we have type of statistics means how many type of statistics you have. So you have statistics type. Yeah. So you have predictive statistics, inferential statistics, differences, associative statistics, and predictive statistics. These kind of statistics are there, in which we'll deal more with descriptive, inferential, and predictive. That's what we deal in machine learning more. Descriptive, inferential, and predictive. They are more important for us as a data scientist or machine learning engineers. Okay, out of these three, predictive, inferential, and predictive, they are more important for us. So these are basic things we will cover. So next couple of lectures are going to be more theoretical. There will not be any numerical samples, numerical examples on this.